Hello and welcome to this demonstration of media quality aware resilience and cross-regional failover for live streaming. I'm Krista Whitehorn and I'm a solutions architect here at AWS specialising in our media services. Live streaming video platforms face a persistent challenge when interruptions, failures or quality degradation occur in the video processing chain. The impact in the form of frozen frames, black frames, drop frames or signal loss reaches viewers almost immediately, resulting in poor quality of experience that negatively affects viewer sentiment. Traditionally, detecting these issues has relied on manual eyes-on-glass confidence monitoring and failover processes, which can take several minutes to resolve, during which viewers may miss critical moments. AWS addresses this with Media Quality Aware Resilience, or MQAR, an integrated capability across AWS Elemental Media Live, AWS Elemental Media Package, and Amazon CloudFront. Let's take a look. Let me first explain what we're seeing here on screen. This is a visual representation of a redundant video architecture we're going to be talking about today. On the left-hand side, we have content being created on-premise and being delivered into our cloud infrastructure via Media Live Anywhere. We're actually delivering into two regions in this example. Our primary region is running a dual encode pipeline, and our secondary region is running just a single pipeline. On the right-hand side, we have CloudFront, which has both Media Package origin servers configured within an origin group. Before we look at cross-region failover, let's first take a look at what is happening within our primary region. The two smaller player windows represent the output from each encoding pipeline. The player on the right-hand side is the output from our Media Package origin. You can see that we're displaying the Media Quality Confidence Scores, or MQCS for short, from each pipeline. This is a value from 0 to 100, which Media Live calculates and inserts into the headers of every segment it delivers to Media Package. We're currently delivering content from our primary path A. Media Package allows you to optionally configure a preferred input. I have currently specified a preference for input 1. What that means is it will deliver content from its first input, in this case, our primary path A, unless encode path B has a higher MQCS. If I degrade the video quality of our primary input, we will see the quality scores begin to drop. We will also see the video freeze on that primary input as I start inserting frozen frames. We will also see that Media Package detects the difference in input and switches to the secondary path. So let's zoom back out again. You will see we're also reading MQCS headers from the output of both origins. CloudFront can use this as a mechanism to determine which origin to direct requests to. It does this by making a GET request to the primary origin, but also a HEAD request to the secondary origin. You'll notice I'm also displaying HTTP response codes for the requests to each origin. I have configured my primary media package to respond with 404 errors if the content to its inputs becomes stale. In other words, if it doesn't have any content to serve, it will return a 404 error message to requests. This allows CloudFront to quickly respond and begin redirecting requests to the secondary origin. We can display this by pausing our Media Live pipelines. So again, we've returned back to our primary path. I will pause that and we'll see Media Package within the primary region switches over to its secondary input. Now I'm going to pause that secondary path as well. In this case, I'm effectively taking our primary region offline. We'll see that media package starts returning 404 errors. And we'll see CloudFront is now serving content from our secondary origin. Let's recover both of these pipelines. So now I've recovered our primary region again. The last thing I want to show is that CloudFront, as well as responding to 404 errors, will also use the quality scores as a way of deciding which origin to serve content from. You should see that our quality score for each of those paths are beginning to drop. You'll now notice that CloudFront is serving content from the secondary region again. So we have now seen how we can use a combination of input switching at the origin and origin selection at the CDN to automatically detect and recover from various types of upstream errors. Thank you for watching.